Hi, in this video we are going to talk about this problem, generating power set of a given set using bitwise operators. So we are given a string that represents a set with these three distinct characters, right? And we want to generate all the subsets of this given string. So subsets of the string are empty string, A, B, C, AB, AC, BC and ABC. For this string AB, we have subsets as empty string A, B and AB. In general, if you have n characters in the input string, then there are 2 raised to the power n subsets. Because for every character, there are two possibilities. Either this character is present in the subset or not present in the subset. So according to two possibilities for n characters, we have 2 raised to the power n total subsets in the power set. Please pause this video and try to think of a solution that is iterative, uses bitwise operators and generates the power set. One hint for power set generation is your power set elements should not be in the same order as they appear here in the output. You just need to generate these power set elements, basically these strings, but the output, the order of these strings can be different. You may have A, B, then AB instead of C. So please try now. Here is an interesting bitwise operator based solution for generating power set. We know that there are 2 raised to the power n subsets or elements in the power set. So what we do is we use a counter variable that varies from 0 to 2 raised to the power n minus 1. So if n is 3, then this counter is going to vary from 0 to 7. We consider the binary representation of counter at every point. When it has 0, we consider this binary representation. When it has value 1, we consider this binary representation of 1. So this is just binary representation of this number, right? And this is how all these numbers are. So we generate a counter from 0 to 7. We consider the binary representation and we use the set bits in this binary representation to generate the corresponding subset. If all the bits are 0, then you say the subset corresponding subset is empty. If the last bit is 1, then you put A. So you put A corresponding to the last bit, B corresponding to the second last bit, and C corresponding to the third last bit. Whenever the last bit is set, you are going to put A in the output. Whenever the last bit is 0, you are not going to put A in the output. Whenever the second last bit is set, you are going to put B in the output. Whenever the second last bit is not set, you are not going to put B, right? So that's how you generate all these subsets. So for 0, you have empty. For this, only this bit is set, so you have A. For this, only this bit is set, so you have B. For this, you have 2 bits set, bits corresponding to A and B, so you print AB. For this, you have only 1 bit set corresponding to C, so you print C. For this, you have 2 bits set corresponding to C and A, so you print AC. For this, you have 2 bits set corresponding to B and C, so you print BC. For this, you have all bits set, so you print ABC. Now we get an idea. We simply generate a value which is 2 raised to the power n minus 1. We run a loop from 0 to this value. In every iteration of this loop, we consider binary representation of this value. We find out which all bits are set in the binary representation and we put characters according to these set bits. Now again, please try to pause this video and try to write down the code after getting this idea. Here is one more example illustration. Say we have a string AB. For 2 characters, we know that we are going to have 0 to 2 raised to the power 2 minus 1 subsets. Right? N is the number of characters in your input string. So you know that you are going to have 0 to 3 values in the subset. Basically, you have 4 subsets. You generate these 4 numbers, take their binary representation, and consider this bit corresponding to A and this bit corresponding to B. So whenever this bit is set, you are going to print A, otherwise you are not going to print A. So here nothing is set, so you empty. This bit is set, so A. This bit is set, so B. Both bits are set, so AB. Here is implementation to generate power set of a given set. We take a string as an input. We find the length of the string, n. if you see this is input, our n is going to be 3. Then we find out the power set size, which is going to be 2 raised to the power n, 8. Right? Now we run a loop from 0 to power set size minus 1, which is our counter, this value. This is binary representation of the counter. For every value of the counter, we traverse through the string, right? So if the counter is 0, we are going to traverse from j equal to 0 to n minus 1, which means we are going to consider the characters A, B, C, right? So what we do is, for every character, we check if the corresponding bit is set or not. So when j is 0, we are basically checking the last bit, which means we are printing the str0 according to last bit of our counter. So if the last bit is 0, then we are not going to get the first character of our input string printed. How does this expression work? Let's take a random value of counter. Let's say we have the counter as 3. Right? Now what we do, so we have already produced output for 0, 1, 2. Now we are at counter equal to 3. So what is the binary representation of counter? It's this, 0, 1, 1. And we are supposed to print AB for counter equal to 3. Now how does this code print AB? It traverses through j equal to 0 to 2, right? So j equal to 0 to j equal to 2, a loop runs. This loop runs for counter equal to 3. Now when j is 0, what happens? You check whether the last bit is set in the counter or not. And how do you check? You do one left shift 0, right? And what do you get? One left shift j is going to be 1 only. So when you do bitwise AND of this number 1 with 3, you are going to get non-zero value, right? So you get a non-zero value, so that is why you print A on the screen, right? You print A on the screen. Then you run this loop one more time, and now your j is 1. So when j is 1, what happens? You look for the number which is shifted by 1. So 1 left shift j is going to be 2, right? Binary representation of this number. Please note that left shifting a number multiplies the number those many times with 2, right? So here we left shift by 1, so which means we multiply it by 2. So we get the value as 2. Now we do bitwise AND of 2 with our counter, and counter is 3. So 3 and 2, if you do bitwise AND of these two numbers, you are going to get non-zero value. Basically, you are going to get the output as 2, right? So what do? You print the jth character of the string. So you print B on the screen. So you have printed A already, now you are printing B after A. Now you again run a loop for j equal to 2, and what happens this time? Our j is 2 now, and we shift 1 by 2. So what do we get? We get 4, right? Which is equivalent to multiplying 1 with 2 raised to power 2. So when you get 4, and if you do bitwise AND of 4 with this counter value 3, this counter variable, what do you get? You get 0, right? Because this 3 has binary representation as this, and 4 has these two bits at 0, and this bit is set. So you're going to get 0, which means C will not be printed. So you only print A and B on the screen for counter equal to 3, right? That's what you print at the end. And then you print a new line, so that new subset for counter equal to 4 is printed in new line. So that's how this logic works. We first compute the power set size. After computing the power set size, we run a counter variable from 0 to power set size minus 1. We consider binary representation of the counter variable. For every bit, we check whether we need to print the corresponding character or we don't need to print. And how do we check? If that bit is set, then we print the corresponding character, otherwise we don't. And after printing a subset for a particular counter, we simply put a new line so that all the subsets appear after a new line. Please note that output of this program is going to have subsets in this order, because your counter goes from 0 to 7. So you will see empty first on the screen, then A, then B, then AB, then C, then AC, then BC, then ABC. So that's how you are going to get output on the screen, not in lexicographically increasing order. What is the time complexity of this program? We run a loop that runs 2 raised to the power n times. For every value of counter, we traverse through all the characters of a string, which takes n times. So the time complexity is clearly theta of 2 raised to the power n into n. That much time is taken by this program to generate all subsets of a given set.